So 2 sets of notes today. Both of them are in Schoology. So you can, again, as always, either take your own notes or use the notes that I've provided, adding summary and questions at the end. So our first note set for today is about gases and pressure. So last unit, we spent a bunch of time talking about properties and characteristics of different solids and liquids. This unit is all about properties and characteristics of gases. So just to have you stop here for a second, I'd like you to start on a left side and just jot down. It doesn't need to be full sentences, but just anything. Everything you can tell me about gases, about them in terms of particles, about them in terms of properties. Just to prime the pump, take a minute, jot down some things, and then come back. All right, so general characteristics of gases. We talked about these a little bit at the beginning of last unit, but unlike solids and liquids, gases will expand to fill their container, right? You can change the volume, are highly compressible, you can change the volume, have extremely low densities. The particles are very spread apart, okay? They're typically non-metals at room temperature, and mixtures are almost always homogeneous. So if you take one gas particle and you take a different gas particle and you put them together, because the particles are spread out, the attraction or the IMFs between them don't usually make much of a difference, and so as a result you end up with a homogeneous mixture. And they tend to be substances that have low molar masses. Again, low molar masses means that their LDFs are small, and so as a result of that, you're going to end up with the high ability or the easy ability to go ahead and turn something into a gas because there aren't IMFs holding it together. So those are some basics about gases. Next, what we're going to do is we're going to explore one characteristic of gases that we haven't talked about yet this year, and that property is pressure of a gas. So pressure is defined as the amount of force applied to an area. Okay, so how hard you're pushing and what area you're pushing over. That gives us our pressure. In terms of gases, pressure, a few different vocabulary terms that have to do with pressure that are important for us. One is atmospheric pressure. If you imagine that there was a cross-section of 1 meter by 1 meter, and all of that force was being pushed down onto an area at the bottom that was also 1 meter by 1 meter, that column of air above all of those particles would be pushing down in that one spot, and that would be known as the atmospheric pressure at the Earth's surface. We live in atmospheric pressure all the time, so we don't really view it as a pressure, but nonetheless, it is there, it is around us, it is pushing on our bodies at all the time. All right, so given that, here we got 2 pictures. We got a picture of a group of people at the bottom of a mountain and a person at the top of a mountain. We'll assume that he's at the top of this mountain up here. Who experiences more pressure? Well, if you think about it for a minute, right? Who's got more air sitting on top of them? It's the people down here on the bottom of the mountain versus the person that's on top. So as we go up in altitude, we experience less pressure in general. When we talk about pressure, there are a lot of different units that we can use. The basic SI unit is the Pascal, and the Pascal is equal to 1 Newton or force per meter square of area. In chemistry, though, we don't typically use pascals. We'd use a unit called atmospheres, and basically an atmosphere is about what the atmospheric pressure of something would be at sea level. And so it's equal to some other units that we have that are oftentimes measurement. One would be 760 millimeters of mercury, 760 torr. You'll notice those numbers are the same. A millimeter of mercury is the same as a torr, or 1.01325 times 10 to the 5th pascals. In chemistry, another term that's important is standard pressure. So that is the normal atmospheric pressure at sea level. Okay, it's referred to as the standard pressure, and it is equal to 1 atmosphere, or 1.00 atmospheres, 760 torr, or 101.325 kilopascals. You will find many of these conversions on your pink sheet, so take a look at that when you get a chance.